Hi, we are going to learn how to assign oxidation numbers to different elements. And this is going to help us when we're naming ionic compounds, when we need to name the charge on those transition metals or metals that can have variable charges. All right, so first of all, what is an oxidation number? Sometimes people call them oxidation states as well. Well, it's going to be a positive or a negative number that we're going to assign to an element that is in a molecule, and it's going to be based on a set of rules that we're going to look at in a minute. You can think of an oxidation number as the charge on the element. All right, so cations come from metallic elements. Remember, metals like to form cations. They like to lose electrons because then they can have an electron configuration similar to those or the same as those of a noble gas. So, transition metals and some metals that are in groups 13 through 15 can have more than just one charge. They can have different charges. And so our job is to be able to calculate and identify the charge on these metals. The way that we are going to show the charge on these metals is by using a Roman numeral in parentheses after the name of the metal. So, this is called the stock system. So for instance, FeCl2 is called iron 2 chloride. And so as you can see here, the 2 here in the Roman numeral in parentheses is the charge on the iron. So it's an iron with a +2 charge. But iron is one of those transition metals that can have more than one charge. So here we see it's FeCl3, so clearly the iron doesn't have the same charge, and this is iron 3 chloride, so that 3 with the Roman numerals is the charge on the iron, or it's iron +3. So cobalt 2, okay, again that Roman numeral is the charge on the cobalt. Cobalt 2 has a charge of +2. Lead 4 is lead with a charge of +4. Notice again, these are all metals and they all have a positive charge. They've lost electrons. Tin 2 is tin with a +2 charge, and gold 3 is gold with a 3+ charge. All of these metals have variable oxidation numbers, and so we have to be specific. We have to say which cobalt or which lead. Okay, so there are metals that always have the same oxidation state, and so we do not need to use a Roman numeral with these metals. So these do not need, they do not need a Roman numeral, so no Roman numeral necessary, because they always have the same exact charge. So we don't need to put a Roman numeral in there. The alkali metals, they are always +1. So sodium, you don't have to say sodium 1, it's just sodium. The alkaline earth metals, they always have a charge of +2, so you don't need to say calcium 2. It's always +2. Aluminum is always +3. Zinc is always +2. Silver is always +1. Cadmium is always +2. Gallium is always +3. So with all of these metals, it is not necessary to use a Roman numeral to indicate the charge on the metal. That's because they always have the same charge. All right, so how do we determine this oxidation number when we're looking at a formula? Well, we've got to follow the following rules, and we have to follow them in the order that they are presented. All right, rules for metals. Okay. Oxidation number of any element that is uncombined with another element is always 0. So if I just had plain old zinc, just like that, the oxidation number or the charge on that zinc would be 0. If I had just plain old sodium, no oxidation state given up here, no charge, it would also be 0. Okay, alkaline metals, like we said, are always +1. Remember, their electron configuration is going to end with an S1. And if they were to lose that one electron to get a +1 charge, they would have a noble gas electron configuration, which is very stable. So that's why they always form +1 and why they're very reactive. The alkaline earth metals, their electron configuration is going to end in S2. They always form +2. They like to lose both of those valence electrons to have an electron configuration that is the same as a noble gas. All right, so alkaline metals +1, alkaline earth +2, all the time. Don't need to use a Roman numeral. All right, fluorine is always -1. So now we're talking about rules with nonmetals. And oxygen is usually -2 unless the second or third rule would be broken. So oxygen is kind of a special case. Most of the time it's -2, but there are a few rare exceptions. There are things called peroxides, you've probably heard of them, and superperoxides. All right, peroxide is when oxygen has a -1 oxidation number, and superperoxides are when oxygen has an oxidation number of -1/2. These are rare, and these happen when we combine oxygen with either a group 1A or a 2A metal. All right, so here we go. Here is sodium peroxide, and this is calcium peroxide and hydrogen peroxide. Okay, sodium has to have a +1 charge. Okay, so we've got 2 sodiums, each has a +1 charge. So we're like, well, what do each of the oxygens, what is the charge on each of those oxygens? If the whole entire molecule here has no charge at all, so it has to equal 0. And when we do this, we see that the charge on oxygen is -1. That's called a peroxide. And again, they're pretty rare. All right, so most of the time oxygen is -2. All right, superperoxides only happen when oxygen combines with potassium, rubidium, and cesium. And so in this particular instance, potassium has to be +1. All right, the oxygen, well, let's figure out what its charge is, and we have 2 of them, and this molecule has no charge. So here we've got that the oxygen has an oxidation number of -1/2. Again, it's very rare. All right, hydrogen. When hydrogen combines with a nonmetal, it's +1. When it combines with those group 1A metals or group 2A metals, it's called a hydride, and all of a sudden it has a -1 charge. So this would be sodium hydride, and the hydrogen oxidation number would be -1. Again, sodium has to be +1. The rules, it's rule number like 2. And so this hydrogen has to be -1, and that's called a hydride. All right, so let's see. The halogens will have a -1 oxidation number when they combine with metals. So remember our halogens, fluorine, chlorine, bromine, iodine. And then the next group over, sulfur, selenium, tellurium, all of these are going to have a -2 oxidation number when we're combining them with metals. And then the nitrogen, the phosphorus, the arsenic, when combined with a metal, will have that -3 charge. All right. So all the other oxidation numbers we're going to have to determine by summing up all the oxidation numbers to equal the charge on the molecule. If no charge is indicated, then the sum of the oxidation numbers will be 0. Let's go ahead and practice. All right, here, let's figure out the oxidation number on the underlined element. We want to know the charge on gold. Okay, well, according to those rules, chlorine is a -1, and we have 3 of them. Okay. All right, then we're going to add gold to it, and we only have 1. And all of this added together equals 0, okay? So we can see that gold is going to be +3. Some people just kind of do the math over here. They say, oh, well, each chlorine's -1. We got 3 of them, so that's -3. So gold has to be +3. We would name this gold, and it's one of these metals where we have to indicate its charge. It doesn't always have a +3 charge. This would be gold 3 chloride. All right, here we go. We've got oxygen, and it has a -2 charge. So what must be the charge on that copper? If you said positive 2, you're right. Notice that the sum of all of these positive and negative oxidation numbers has to add to 0 because there's no charge there. So this would be copper. What did you figure out the charge to be? Positive 2? Good. Copper 2 oxide. Here we've got 2 coppers, and both of those coppers have to add up to have a charge equal to -2. So here we go. Each of these coppers, so we've got 2 coppers, and we're going to add to that the -2 from oxygen. And when we add up copper's positive charge with oxygen's -2 charge, it has to equal 0. So here we see that each copper has a positive 1 charge. And so the name of this is copper 1 oxide. So that's a little bit tricky because both of those coppers added together has to have a positive 2 charge to balance out the -2 from the oxygen. All right, here we go. This one shouldn't be too bad. Okay, we have 3 chlorines, and each chlorine is -1, plus whatever iron's charge is going to equal 0. And so we find out that iron is a positive 3 charge. The name of this would be iron 3 chloride. All right, down here, lead. We have 2 oxygens, and each oxygen is -2. We don't know what lead's charge is, but the overall thing, the positives and the negatives equal 0. So here we have lead equal to a positive 4, and so the name of this is lead 4 oxide. We're going to practice this a lot in class. Notice that all of these metals are metals that can have more than 1 charge, and that's why we're having to figure out the charge, and then we're having to indicate its charge by Roman numerals in parentheses. All right, let's go ahead and now let's assign the oxidation number of some things that aren't just metals. All right, we're going to use our same set of rules. This gets a little more complicated. Okay, here we go. Sodium, always +1. Oxygen, we've got 4 of them. Each are -2. We would like to know the oxidation number on the chlorine atom. All right, all of this added together has to equal 0 because the overall molecule has a charge of 0. So we're going to do like a little algebraic expression. +1 from the sodium plus whatever chlorine happens to be, plus that -8, the 4 times -2 from the oxygen has to equal 0. So here we're seeing that chlorine has an oxidation state of +7. All right, let's go down here to the carbon. Okay, this is lithium carbonate, but let's figure out the oxidation number on carbon. We have 2 lithiums. Lithium's an alkali metal. It must be +1, plus the carbon and 3 oxygens that are -2. All added together will equal 0. So we have got carbon equal to a +4. Here is something different. It's a polyatomic ion, and so all the oxidation states added together for this has to equal -1. So let's figure out the charge on the manganese. Mn, we have 4 oxygens, each are -2 in charge, and the whole thing has to equal -1. Up to this point, we haven't had any charge up there, so we've been setting it equal to 0. When there's a charge indicated, know that all the charges in the molecule have to equal up to that number. All right, so here we see that manganese has a big number. Its oxidation number is +7. And last but not least, again, another polyatomic ion. This one's called dichromate. We have 2 chromiums. We would like to know what the charge is on those chromiums. We have 7 oxygens, each are -2, and everything has to equal -2. All right, and so we've got 2x being equal to 12, and so chromium's oxidation number is 6. All right, and so there we have it. Now we're going to practice a lot with these oxidation numbers, but you do need to know those rules. So remember, alkali metals +1, alkaline earth are +2, and just review all those rules that were in this PowerPoint, and then we're going to practice, practice, practice. This will help us name our ionic compounds, as well as just now we know how to determine the charge on an element in a molecule. Thanks a lot. See you later.